This is Module 1, Lesson 3. We're going to talk about multiplying and dividing numbers in exponential form. Now, down here we've got the abstract versions of this. I want to actually run through a multiplication one and a division one and show you how these work. If I have, say, 2 to the third power times 2 to the fourth power. When I'm multiplying, what I do is first I go ahead and convert this to general standard form. 2 to the third power is 2 times 2 times 2. 2 times itself 3 times, okay? I've substituted 2 times 2 times 2 in place of 2 to the third power. Now, let's multiply that by 2 to the fourth power. That means 2 multiplied by itself 4 times. 2 times 2 times 2 times 2. 2 to the third power times 2 to the fourth power. Okay, what does that actually give me? Well, all of these are the same bases. They're both 2. So that would be 2 to the, how many times am I multiplying 2 by itself? 1, 2, 3, 4, 5, 6, 7. 2 to the seventh power. Now notice, there's an easier way to get by this. If we are multiplying and we have the same base, our base here in this case is 2, and we're multiplying, all I need to do is add the exponents. That would be 2 to the 3 plus 4 power. See, I added the 2 exponents, which is 2 to the seventh power. Notice, I can either expand this out, substituting in, the standard form versus the exponential form, or I can realize I have the same base and add the exponents. They give you up here a general equation for this. X raised to the m power times x raised to the n power. Remember, if you've got a dot, it means times. X to the m power times x to the n power equals x to the m plus n power. You just add the exponents. Now let's look at a few questions where we would use something like that. And here's the same thing up here. 14 to the 23rd power times 14 to the 8th power. I am multiplying here. I have the same base, so all I need to do is add the exponents. That's 14 to the 23 plus 8 power. 23 plus 8 would give you 31. 14 to the 31st power. Let's do number 2. I have negative 72 raised to the 10th power times negative 72 raised to the 13th power. Now I have to keep the negative 72 in parentheses, remember, because I'm multiplying negative 72 by itself 10 times here and by itself 13 times here. If I just put the no parentheses, it would just mean the opposite of 72 raised to the 10th power. So let's be careful when there's a negative sign here or it's a fraction, you put it in parentheses. Negative 72 to the 10th power times negative 72 to the 13th. I would add my 2 exponents, 10 plus 13, and I've got negative 72 raised to the 23rd power. Now, I know this has nothing to do with the multiplication part, but in a previous unit, we talked about whether this would be a positive or negative number based on the exponent. Remember, if your exponent is odd and you're talking about a negative number, your result, your product would be negative, right? Okay. That's why they use the parentheses. Exercise 3. I have 5 to the 94th power times 5 to the 78th power. I'm multiplying. I have the same base, which is 5, so I add my exponents, 94 plus 78. That gives me 5 to the, now let's add 94 and 78. You don't get a calculator for this material, this whole unit, so let's make sure we know not to use a calculator. 8 plus 4 is 12, we carry our 1. 9 and 1 is 10, plus 7 is 17. 5 to the 172 power. Now we've got negative 3 to the 9th power times negative 3 to the 5th power. My base in this case is -3. Notice we put that in parentheses, so we know we're multiplying -3 times itself 9 times, and it's by itself 5 times. Okay, so this is -3 to the 9 plus 5 power. I would add these, -3, 9 plus 5 is 14. That's -3 to the 14th power. That means we multiply -3 times itself 14 times. If I were to do this, guys, this is a positive number, or this is an even number, so this would be a positive result. Exercise 5, let A be a number, a to the 23rd times a to the 8th. Isn't that exactly what you had here? Okay. So when I've got A, it's the same base, and I'm multiplying. See, that dot means multiplying. I add my exponents. That would give me A to the 31st power. How about this one? F to the 10th times, that dot means multiply, F to the 13th. I have the same base, which is F. Keep my base, add my 2 exponents. That gives me F to the 23rd power. If you've got B to the 94th power times B to the 78th power, B is our base for both of them, so we keep our base. We add our exponents, 94 plus 78. And see, we did that one over here. We just did it with 5 as a base. When you add them, you would have B to the 172nd power. See, variables work just like numbers for bases. Now let's look at this bottom one down here. Let x be a positive integer. If -3 raised to the 9th power times -3 raised to the x power equals -3 to the 14th power, what is x? Well, we know that if we're multiplying, we add our exponents. 9 plus, in this case, is x. We don't know what it is. And that gives us our final thing here, our final exponential expression. Let's just add our exponents. 9 plus x equals 14. How do we find x? We need all of our variables on one side, all our numbers on the other. This 9 is added to x, put my line through the equal sign. When I cross the equal sign, I do the opposite of what's there. If that's a positive 9, then I would be subtracting 9, and I do it on both sides. That leaves me with x is equal to 5. So the equation would be -3 to the 9th power times -3 to the 5th power equals -3 to the, remember, if you have the same base, you add your exponents, 14th power. Okay, so it does work, doesn't it? All right. I'm going to skip over this page because you've got a lot of homework on here. And let's see. Oh, wait, I think I wanted to do one that had some, oh, here's one. What if we've got 3 different exponents here? -9 to the 4th power times 9 to the 6th power times 9 to the 13th power. I add those together. That's 9 to the 4 plus 6 plus 13. That gives me 9 to the, that's 10, 23rd, right? 9 to the 23rd power, okay? What if I've got one like exercise 11 here? I've got different bases. Well, let's collect the bases. I've got 6 to the 5th power times 6 to the 14th power. Okay, that takes care of that base of 6. Times 4 to the 9th power times 4 to the 3rd power. All I did was rearrange. I'm sorry, that's 4 to the 3rd power. Now let's take care of this base of 6. That would be 6 to the 5 plus 14, or 6 to the 19th power, right? Times, and I've got 4 to the 9 plus 3, or 4 to the 12th power. There would be my answer, 6 to the 19th power times 4 to the 12th power. I don't need to go any farther. I've collected my like bases and taken care of them. All right, let's see. We're not worried about 17 or 18, but y'all do have, y'all are going to wind up doing these other exercises, 10, 14, 15. You'll wind up doing those. Now I want to look at dividing. Oh wait, I think there was one other on here I wanted to look at. What happens when you've got a situation like this, okay? You've got coefficients, you've got bases, and you've got exponents. Let's collect our coefficients. We just do to our coefficients what's there. That's 2 times 17. Now that leaves us x to the third times x to the seventh. 2 times 17 is 34. I've substituted 34 in place of 2 times 17. X to the third times x to the seventh. When I'm multiplying like bases, in this case the x's, I would add the exponents. 34 times x to the 3 plus 7, which gives me 34 times x to the 10th, okay? Why did I multiply these instead of adding them? These are coefficients. They're in front of our base. 2 and 17 are coefficients. The x is our base because that is what your exponent is on, okay? Now, let's look at how to handle division. If we're adding and if we're multiplying and we add, would it make sense that if we're dividing, we'd subtract the exponents? Let's try an example. What if I have 2 raised to the 5th power divided by 2 raised to the 2nd power? Let's write that out. 2 raised to the 5th power. That is 2 times itself 5 times. 1, 2, 3, 4, 5. Okay. 2 to the 2nd is 2 raised to itself 2 times. So I can cancel these. This 2 is gone. That 2 is gone. This leaves me with 2 to the 3rd power. Let's try just subtracting the exponents. When you divide, you do the opposite of the multiplication. So 2 to the 5th power divided by 2 to the 2nd power. That's 2 to the 5 minus 2 power, or 2 to the 3rd power. Okay? Let's try one of these down here together. I'm going to do the 8/5 for you. Or let's do this one first. 7 to the 9th divided by 7 to the 6th. That would be 7 to the 9 minus 6, or 7 to the 3rd power. 8/5 to the 9th divided by 8/5 to the 2nd. That would be 8/5, and when you know we put this in parentheses because it's a fraction, to the 9 minus 2 power, which is 8/5 raised to the 7th power. Okay? That covers multiplication and division if you're involving exponents. Let me try one other thing. What if you had a question that looks like this? 6x to the 7th power divided by 3x to the 1st power, x to the 2nd power, okay? I would divide this up, guys. These are coefficients. Remember a minute ago when we dealt with coefficients, we kept the coefficients together. So what I'm looking at really is 6 divided by 3, 6 over 3, x to the 7th divided by x squared. 6 divided by 3 is 2. That would be 2 times x to the 7th over x squared. When I have the same base and I am dividing, I subtract the exponents. That would give me 2x to the 5th power, okay? There's one other thing I want you to know. What if you encounter just an x? What if you had x to the 5th divided by x? When I've got nothing on the x, that's the same as x to the 1st power. This would be worked this way, x to the 5 minus 1, which is x to the 4th power. Okay, that covers multiplication and division on exponential notation.